Welcome to Book Doctor Technologies. This video is an introduction to a series of videos on hyperbolic functions. But before we begin, we need to understand trigonometric function. Hyperbolic functions are extension of trigonometric functions. A proper understanding of trigonometric function will aid our understanding in hyperbolic function. Trigonometric functions are defined on the unit circle with the equation x squared plus y squared is equal to 1. And the unit circle is shown on the diagram. This is the unit circle. And it passes through some coordinates such as 0, 1. Sorry, 1, 0. 0, 1, yes. 0, 1, 1, 0. Then we have negative 1, 0 and 0, negative 1. Good. And all these points and any other point that will be picked on the circumference of the circle will have to satisfy this equation. X squared plus y squared is equal to 1. X squared plus y squared is equal to 1. For instance, negative 1 squared plus 0 squared will give us 1. 1 squared plus 0 squared will also give us 1. And likewise, 0 squared plus negative 1 squared will also give us 1. Good. I have marked a point on the circumference of the circle. Let's call that coordinate S1, Y1. The X coordinate can be obtained by finding the magnitude of this line called B. The X coordinate can be obtained by finding the magnitude of B. Let me even call here X1. Then the Y coordinate, which is here, can also be found by finding the magnitude of this side, which is A. Let us use basic trigonometry ratios, the SOHCAHTOA, to identify the values of these angle lines, the A and B. To find A, we know that A is opposite the angle in question. So we are going to use sine. Sine theta is equal to A over 1. The reason why it is over 1 is that this is a unit circle. The unit circle has a radius of 1. From the origin to the point negative 1, 0 has a dimension of 1 unit. Similarly, from here to 0, negative 1 has a magnitude of 0 and 1 unit. And then from 0, 0 to this point is also a radius. So this also is going to give us a dimension of 1 unit. So the hypotenuse here, which is the radius, is having a unit, a magnitude of 1 unit. So sine theta will be equal to A over 1. Simplifying further, we can see our A is equal to sine theta. Then for the B, we will use cos. Cos theta, which is adjacent of our hypotenuse, will be B over 1. Simplifying further, we can see our B is equal to what? Cos theta. So to find the coordinate x1, y1, we can actually use the basic knowledge of trig. So my x1, y1 coordinate can be written as cos theta, comma, sine theta, where cos theta represent our B, our side B, which is the x coordinate, and then sine theta represent the side A, which is our y coordinate. If this is true, it should satisfy the general equation of a circle, the general equation of the unit circle, which states that x squared plus y squared is equal to 2. Remember, they stand for x and they stand for y. So this should satisfy the equation of the unit circle. So cos squared theta representing x squared plus sine squared theta should give us 1. And in fact, it is 1. This is one of the identities in trigonometry. Cos squared theta plus sine squared theta will give us a value of 1. For example, if I have theta is 90 degrees. cos square 90 degrees plus sine square 90 degrees. Sine square 90 degrees. Let's see the value. Cos square 90 is 0 and sine square 90 is 1, and it's giving us 1. You can try for all angles and you can see that it is indeed true. It satisfies the equation x squared plus y squared is equal to 1. Good. So any point on the circumference of this circle can be written in that form. For example, if I want the coordinate here x1, x2, y2, this is our 1. Let's call this one s2, y2. We just need to find the angle here. The angle this line will make with the positive x-axis. Once you know the angle it makes with the positive x-axis, then the cos of that angle squared plus the sine of that angle squared will give us 1. Let's try this side and see. And the line here makes an angle of 180 degrees with the positive x-axis. This will also imply cos square 180 degrees plus sine square 180 degrees should give us 1. If we use calculator to find cos square 180, we are going to get positive 1, because cos 180 is negative 1 plus sine square 180 is 0, and indeed is also giving us 1. So this satisfies the equation of a circle. So cos square theta plus sine square theta is equal to 1, and it's indeed coming from the idea that the equation of the unit circle is given by x squared plus y squared is equal to 1, and the x coordinate can be written as cos theta, and the y coordinate can also be written as what? Sine theta. Now let's go to the hyperbolic function. The hyperbolic function is not based on the unit circle, but rather the hyperbolic function, the hyperbolic graph, the hyperbola. On our screen here is a hyperbola. The hyperbola, we have two curves. One reflects the other as shown, this side and this side. And the equation of the hyperbola is x squared minus y squared is equal to 1. Note the difference. The unit circle, its equation is x squared plus y squared is equal to 1. And the hyperbola, its equation is x squared minus y squared is equal to 1. The difference lies in the addition and the subtraction. And addition and the subtraction. Good. The hyperbola, the unit hyperbola passes through the coordinate 1, 0 here. And then it also passes through the coordinate negative 1, 0. And it never touches the line y is equal to x or y is equal to minus x. In fact, these two lines are the asymptotes of the hyperbolic graph, the hyperbola. It never touches them. Even looking at the equation x squared minus y squared is equal to 1. There is no way y will be equal to x. Anytime y is equal to x, it will not satisfy this equation. Or anytime y is equal to minus x, it will not satisfy this equation. For instance, when x is equal to 3 and y is equal to 3, you are going to have 3 squared minus 3 squared, and that indeed will give us 0, not 1. So it shows that y is equal to x or y is equal to minus x cannot satisfy this equation. So these two lines, the y is equal to x line, which is the yellow line, and then the y is equal to minus x, which is the violet line, are the asymptotes of the hyperbola. Good. Now let's come to the graph itself. Let's mark this position x1, y1. Remember, after marking this position, I can draw a line to this side, draw another line to the origin, and then the angle, the line make with the positive x-axis, let's call it theta. Unlike the unit circle where our hypotenuse is 1 because it is picking the radius of the circle. When it comes to the hyperbola, this line, which is the hypotenuse, doesn't have a value of 1 because the coordinate 1, 1 actually ends here. So the length h, marked h, will not be 1, will not pick the unit circle 1. Good. So let's continue. Like how we find an expression for a and b, if we want to use the same knowledge as in trigonometry to find an expression for a and b, we can say sine theta is equal to opposite, which is a, over our hypotenuse, and then our a will be equal to h sine theta. Then for b, let me just write it straight away. B is also represented by h cos theta. Good. This two relation should satisfy x squared minus y squared is equal to 1. Should satisfy x squared minus y squared is equal to 1. Like how the sine cos squared theta plus the sine squared theta satisfy all points on this unit circle. This should also satisfy all points on this hyperbola, such that if, for example, I mark another point here and I draw a line to the origin, the angle it makes here, if I pick it, it should also satisfy that relation x squared minus y squared. This, as we have realized, the value of the a can be expressed as h sine theta and b can be expressed as h cos theta. This should imply h cos theta and h sine theta should satisfy the relation x squared minus y squared is equal to 1. So for any angle within this range, for example, if I should pick a point somewhere here again and draw, and then find the angle there, it should satisfy this range. For that matter, the h sine theta, h cos theta is best written as sine with an h theta, where the h here is not a variable, like how the h is a variable here, we should have found the value. No, the h here is not a variable, but the sine with an h turn the whole expression into another function, which we called the hyperbolic function. So when I write sine with an h theta, it means my reference angle theta is not coming from the unit circle, but rather from the hyperbolic function or the hyperbola. If I write cos with an h theta, it means my reference angle theta is not coming from the unit circle, but from the hyperbola. Same way we can have a tan with an h, or otherwise called a tangent or hyperbolic tan. So when I have hyperbolic tan theta, it means my angle in reference is not coming from the unit circle, but from the hyperbola. So that is a clear distinction between normal trigonometric functions and hyperbolic functions. Hyperbolic functions are defined on the hyperbola, whereas the trigonometric functions are defined on the unit circle. And I want to repeat again, when you see the h in front of the sine or the cos or the tan, they are not variables to be determined, but rather they are indicating that the angle in reference is from a hyperbola, and as such the expression is a hyperbolic function. Good. Now, sine theta, or the sinh of any angle, let's say x, can be expressed in the form of an exponential function. The sine s, or the sine of any angle, let's say x, if we want to express the hyperbolic sine x, if we want to express it in the exponential form, it will be e power x minus e power negative x all over 2. And then the hyperbolic cos x is also defined as e power x plus e power negative x all over 2. This is the basic. Once you know these two, all other things, all other trigonometric hyperbolic functions are based on this one. In the video that comes, we will try to use these basic hyperbolic functions to determine the rest, such as hyperbolic tan, hyperbolic cotangent, hyperbolic secant, and then hyperbolic cosecant. And then we'll also prove that cos square x, or cos square theta, minus sine square theta, or square s, is equal to 1. Because if this is defined on the hyperbolic function, then it should satisfy the hyperbolic equation, which says that x squared minus y squared is actually equal to 1. So the videos that comes will try to prove that one. Thanks for watching, and don't forget to subscribe. Bye for now.